Hello, today we're going to be going over our 4.5 notes, which are inequalities. Our learning target is I can represent the solution set of a linear inequality by graphing in slope-intercept form to make sense of real-life situations. I can write a linear inequality in slope-intercept form from tables, graphs, and verbal descriptions. I can use representations to make sense of and solve problem situations. That's weird. I can represent the solution set of a linear inequality in two variables by graphing in standard form to make sense of real-life situations. And I can write a linear inequality in standard form from tables, graphs, and verbal descriptions. I can use representations to make sense of and solve problem situations. Again, that sounds weird. The only vocab word that we have today is a solution set, and a solution set is an area of a coordinate plane that contains all possible solutions to a graphed linear inequality. Oh, why is that so large? Let's adjust that. There we go. Solutions to a graphed linear inequality. Before we begin, let's talk about the differences between equations and inequalities. So when we talk about equations have equal signs, and inequalities obviously have inequality symbols. A solution with an equation is typically only one answer. So for example, if we have x equals 4, that means that x is 4 and nothing else. With an inequality, however, if we have something like x is greater than or equal to 4, that means that x can be 4, but it can also be anything bigger than 4. So when we work with inequalities, we have to do shading because shading represents all possible solutions, whereas an equation will only have one solution. And then I just kind of explained to you what this means in words. There is only one possible solution. Over here, you can have many possible solutions. So we are going to review how to graph a single variable inequality. You did this a lot in middle school. So we have right here that x is greater than 3. So I always put my number in the middle. I put one thing that's bigger than and one thing that is smaller than. We're going to put a circle over 3. Now, the question is this circle going to be an open circle or a closed circle? And we get that information based on our inequality symbol. Because there is no equal sign, this will be an open circle. And then we read this as x is greater than 3. So what I'm going to do is I'm going to shade the side of the number line that represents all possible values that are greater than 3. If I have something like this, I've got -4, I've got -5, and I've got -3. I have a circle on top of -4. Because this has an equal sign, this is going to be a closed circle. So I'm going to fill this in. And then this says x is less than or equal to -4. So I'm going to shade all of the possible solutions that are less than -4. Notice that I shaded the side of the number line that has -5. As I continue on, remember that I'm going to have -6, -10, so on and so forth. And every number that is to the left of -4 is a solution. If I were to plug that in to x, all of those numbers should be less than or equal to -4. So the shading helps us represent all possible solutions to those single variable inequalities. And we do have to think about this whenever we graph two variable inequalities, which is what we're going to do today. Before we graph, we are going to determine if a coordinate is a solution. And I think we've done this before with equations. It says, is 1/6 a solution to the inequality y is less than or equal to 4x minus 2? 1 is going to be our x and 6 is going to be our y. And I'm going to plug those numbers into my inequality over here. Did not do that right. 4 times 1 minus 2. We have 6 is less than or equal to 4 minus 2. We have 6 is less than or equal to 2. Is 6 less than or equal to 2? The answer is no, so that is not going to be a solution. I'm going to do the same thing down here. Here's my x, here's my y. We've got -1 is greater than or equal to -1/2 times -4. So many negatives in here, minus 3. We have -1 is greater than or equal to 2 minus 3. We have -1 is less than or equal to -1. This is true. -1 is not greater than -1, but it is equal to -1. And so because of that, we can say that, yes, this is a solution. If this same problem existed and I did not have that equal sign down there, then that would not be true. -1 is not greater than -1, but I do have an equal sign, so because of that, it is true, and it is a yes. All right, let's talk about graphing two variable inequalities. Graphing inequalities is similar to graphing equations, except your line could be solid or dashed. And solid or dashed represents open and closed circles, by the way. So this is going to be solid or closed circle, or you can have dashed, which is the same thing as having an open circle. And because we have many solutions that could work for our inequality, we need to shade our graph to represent all possible solutions. So remember, up here we had open and closed circles and we had shading to represent our solutions. Two variable inequalities are going to do the same thing. Instead of having an open circle or a closed circle, we have a solid line or a dashed line, but then again we have to shade. So anytime that we are talking about graphing two variable inequalities, you can make this little table for yourself to help you know what you're going to do based on the inequality that you see. So solid lines have to have an equal sign on them. Dashed lines will not have an equal sign. So our solid options are either going to be less than or equal to or greater than or equal to. Okay? Above means I'm going to be shading above my line, and that's going to be greater than. So I'm going to put over here greater than. And then below means that I'm going to be shading things that are less than my line. So if we think about this, solid lines greater than, this is going to be greater than or equal to, and then below is going to be less than or equal to. A dashed line is the same thing as an open circle. So that is going to be an inequality symbol that does not have an equal sign on it, okay? So if you want to, you can come over here and remind yourself that this is a closed circle, and over here, this is an open circle, okay? So notice that we have an inequality sign over here, so before we do anything, we should be able to say, okay, I know that I'm going to be shading above, and I'm going to have a solid line. But that's why we make that table. It's just going to help us figure out what we're doing. All right, it says graph the following inequalities, then list a solution in the solution set and a solution outside of the solution set. So in order for us to graph, we want our equation in a graphable form, such as slope-intercept or point slope. When in doubt, just make everything slope-intercept form because we've graphed this thing 100 times by now. The slope of this line is going to be 3/1. My y-intercept is +1. And so I'm going to go ahead and just graph that like I would normally graph that. 0, 1 is here. And then my slope is up 3/1. I could also go down 3/1. Down 3/1. Okay. The inequality symbol is going to help us determine whether or not we have a solid line or a dashed line, and if we're shading above or below. So the equal sign means that I'm going to have a solid line, and you can put over here if you need to, equal sign. And this is also a greater than symbol, which means that I'm going to be shading above. Okay, so because my line is solid, it's actually just a normal line that you have drawn before. And then we have to shade, okay? So shading, it tells us that we're supposed to be shading above our line. This over here is above my line. So a solution is going to be anything that falls inside of the shaded side. So I'm just going to grab this coordinate right here. Your solution does not have to match my solution, but it does have to be inside of the shaded portion. That is a -2, +2, and then something that is not a solution is just something that is not in the shaded portion. This would be 3, 1. Okay, so as long as you know how to graph a line, graphing an inequality is not that much different. We just have to know whether or not our line is solid or dashed, and if we are shading above or below. Okay, so when I look up here, remember that that is this. That sign is that. It was a solid line, and we did shade above. Okay. When I go to number 2, this inequality is not in a form that I can graph, so I'm actually going to start this by rearranging it. I'm going to move 6x over. So I now have -2y is greater than -6x plus 12. I'm going to divide everything by -2. And we get that y is, my inequality symbol has to flip because I just divided by a negative. This is 3x minus 6. This is going to be off my graph, whoops-a-daisy. But this is what I'm going to end up graphing. Okay, the slope of my line is 3 over 1. My y-intercept is now 0, negative 6. I'm going to do that first. 1, 2, 3, 4, 5, 6 is down here. Sorry about that. I'm going to go up 3 over 1, up 3 over 1, up 3 over 1, and I can't do any more. All right, now I need to determine if my line is solid or dashed. So I have to look at the inequality symbol. Remember that the inequality symbol is going to help me know if I have a solid line or a dashed line. Because there is no equal sign, it's going to be dashed. There is no equal sign. And then that is the less than symbol. Y is less than all of that stuff. So now I have to shade below. So I'm going to go ahead and draw a dashed line, which is just a bunch of little tick marks like this. You do still need arrows on this. And then I am supposed to shade below my line. Below my line is over here. I need something that is a solution. So anything that's inside of the shaded portion of my graph will work. That is 1, 2, 3, 4. This is 4, 1. And then anything on the outside can be a solution. That's 0, 1, 2, 3, 4. All right, taking a look at number 3, although this looks really, really close to slope-intercept form, it is not because there is a negative 1 in front of y. So I have to divide everything in here by a negative 1. When you divide by a negative, remember that your inequality symbol flips. This will become a negative 2/3 x plus 4, and this is what I have to graph now. So my slope is negative 2 over 3, or I could make this a 2 over negative 3. You just have to pick and choose where you want that negative to go, but it can't go to both. Your y-intercept is 0, 4. And then I'm going to go ahead and look at my inequality symbol. I'm going to come over here. Whee! All right, there is no equal sign, so that means that my line is dashed. And now that says y is greater than. So this is going to be dashed and above. So let's plot the y-intercept first. 1, 2, 3, 4. And then I have a slope of negative 2/3. So down 2 over 3. And that's really all I've got. All right. I need a dashed line. So here we go. There is my dashed line. And then I need to shade above. Ooh, I don't have very much space to do that. Very good. All right, something that is in the solution set is that coordinate right there, 1, 2, 3, 1, 2, 3, 4. So this is 3, 4. And then not a solution can be anything outside of the solution set. We're going to go there. That is negative 1, 1. Again, your coordinates for a solution and not a solution don't have to match mine, but they have to be on the same side of either the shaded for a solution or the non-shaded for a non-solution. All right, looking at number 4, this is actually already in slope-intercept form, so I don't have to do any rearranging of anything. My slope is negative 1/2, or I could do this as a 1 over negative 2. My y-intercept is 0, 3. This inequality symbol has an equal sign on it, so because there is an equal sign, this is solid. This is y is less than, so that is below. So I'm going to start at 0, 3. And then negative 1 over 2 means that I'm going to have a slope that goes this way. It is a solid line, so I just draw a good old regular solid line. And then I'm supposed to shade below, which is all of this space. It's so much space. All right, something that is a solution is this guy right here. So I'm going to say 0, 1 is a solution. And then I'm just going to pick this coordinate out here, 1, 2, 3, 1, 2, 3, 4. So 3, 4 would not be a solution. Okay, before I get down to writing equalities from a graph, I think it's important for me to go back up here and show you what something means to be a solution and not a solution in terms of a graph. So we actually talked about things being a solution or not being a solution when I plugged those things in up here. So basically what we're asking is, without graphing, would 1, 6 here, would this thing right here fall in the shaded portion of your graph? Well, you can plug it in and mathematically figure it out. Because this did not work out, this would actually be a coordinate in the non-shaded area. And then vice versa down here, is negative 4, negative 1 a solution? Yes, because it works out. That means that if I were to graph this and grab point negative 4, negative 1, it would be in the shaded portion of my graph. So I'm just going to look at this one. This is the first one that we actually graphed. I'm going to test my solution by plugging it back into my inequality. This is my x, this is my y. We have 2 is greater than or equal to 3 times negative 2 plus 1. This is 2 is greater than or equal to negative 6 plus 1. This is 2 is greater than or equal to negative 5, which is true. If I were to plug in not a solution in here, this is my x, this is my y, we have 1 is greater than or equal to 3 times 3 plus 1. That is 9 plus 1. And right now we are saying 1 is greater than 10, which is not true. So that's how something is a solution or something is not a solution. You can mathematically figure it out if you're not sure. I'm going to go ahead and erase this though, but that's how we could determine it without graphing. Okay. Now what I have to do is go backwards. I'm going to give you a graph. It's clearly an inequality, and I have to determine the equations. Okay, now these first two want slope-intercept and point-slope, and then the last two want standard form. We're going to start with the slope-intercept and point-slope. So anytime you are asked to write an equation, I want you to do two things. First thing I want you to do is find your slope. Second thing I want you to do is find your y-intercept. Third thing I want you to do is find a point on your graph, and then the last thing I want you to do is write down all possible inequalities that we could use here. Okay, so you're going to do this for every time. First thing we're going to do is find our slope. So I have to go to my graph, and I have to find some nice coordinates, and I really only have those two. So remember, slope is rise over run. So we're going to go up 3, and then to the left 1. So my slope is negative 3. Your y-intercept is located at the y-axis, that is 0, negative 2. And then I need a point on my graph. You are always welcome to use the y-intercept. I think some teachers prefer you to use the y-intercept, but you could also use this coordinate over here, which is negative 1, 1. It does not matter which one you choose. I'm going to choose negative 1, 1 just because that's what I want to do. And then on number 4, we are going to do a process of elimination to determine which inequality symbol we have to use. First thing you do is look at your line. Is your line solid or dashed? My line is dashed, which means that the ones with equal signs do not work here. Okay? Equal signs mean that my line is solid. This line isn't solid, it's dashed. Now the next thing I need to do is determine if I shaded below my line or above my line. Below my line means less than, above my line means greater than. And if you look at this, you shaded below your line, which is less than. So that is the inequality symbol that I am going to choose. Slope-intercept form is y equals mx plus b. So my slope-intercept will be y is less than negative 3x minus 2. So that's me looking at my slope, my slope and my y-intercept, and also my inequality. Okay, all of those things. Here's my slope, here's my y-intercept, here's my inequality. Okay, now for point slope form, that's y minus y1 equals m times x minus x1. This is going to be, this is going to be y minus 1 is less than negative 3 times x minus x1. And there we go. Okay. Every time we're going to do these 4 things. So let's come over here to number 2 and let's do it again. But this time we're going to do it over here. We are looking for our m, our y-intercept, a point we want, and then we are going to do a process of elimination with our inequality symbols. First thing I need to do is grab some coordinates from my graph. My slope is up 1 to the right 1, so my slope is 1. My y-intercept is here at 0, 3. I'm going to use this as my point. That is negative 1, 2. My inequality symbol, my line is solid, so I'm going to have to use one of the 2 inequality symbols with an equal sign on it. I shaded below, so that's a less than again, so that's the inequality symbol that I'm going to be using. Slope-intercept form is y equals, or our inequality symbol, so y equals mx plus b. So there's my slope, my y-intercept, my inequality symbol, and then point slope form will be y minus 2 is less than or equal to 1 times x minus plus 1, and there's my equation, or my inequality, excuse me, in point slope form. Again, number 3, we've got our m, our y-intercept, a coordinate, and then our 4 inequality options. Come into my graph, I'm going to grab some coordinates. Whee. All right, up 1, 1, 2, 3, 4. So my slope is 1/4. My y-intercept is here at 0, -3. I'm going to look at this coordinate over here, which is 4, -2. My line is dashed, so it's not going to be one of those two things, and I actually shaded above my graph this time, so I have to use the greater than symbol. So we have y is greater than 1/4 x minus 3. That's my slope-intercept form. Point slope form, we have y minus 4 is greater than 1/4 x plus, oh man, it's twice now I've done that. This should be y plus 2, and then this should be x minus 4. Now, one thing that is different about this is I actually need to write an equation in standard form. So what I am going to do is I'm actually going to convert slope-intercept form into standard form. You could convert your point slope form. It doesn't really matter. I'm just going to do this one because I want to. I don't know. All right, first thing I need to do is get my x's on the same side. So I'm going to subtract 1/4 x. And right now I have -1/4 x plus y is greater than -3. In order to make my a value a positive and not a fraction, I have to multiply everything in here by -4. And when I do that, I will get a 1x minus 4y. I just multiplied by a negative, so your inequality symbol has to flip. And then a positive 12. Woo! And there's my inequality in standard form, okay? You could have, like I said, you could have converted from point slope form to get that, but you're going to get the same thing. You need to pay very close attention, though. When you multiply by a negative, you got to flip your inequality symbol. Okay, and then one more. Let's do, what color have I not done yet? Pink. Gorge. All right, we need M. We need our y-intercept. We need a point. We need our 4 inequality symbols to choose from. To do slope, remember, we're just going to grab a couple of coordinates here. My slope is +1 over -2, so it's a -1/2. My y-intercept is the origin. It's 0, 0. I'm going to grab this coordinate right here, which is -2, +1. Inequality symbols, I have a solid line, so those two do not work for me, and I shaded above, so I need this one. Slope-intercept, y is greater than or equal to -1/2 x, and then you could put +0 at the back if you wanted to, but we don't need to. And then for point slope, we have y minus 1 is greater than or equal to -1/2 x plus 2. Now to get my equation in standard form, I'm going to convert my slope-intercept form. Y is greater than or equal to -1/2 x. I'm going to add 1/2 x to both sides. When I do that, there's nothing on the right side of my inequality symbol, so I need to make sure that I put a 0 there. So right now we have 1/2 x plus y is greater than or equal to 0. I cannot have... my a value can't be a fraction, so I'm going to multiply by the denominator, and we go wee, and that will leave me with 1x plus 2y is greater than or equal to 0, and that is my equation in standard form. Again, you could have converted out of point slope form. It doesn't matter, but there's no way that you can just grab things and put them into standard form. You always have to convert, so that is us doing our conversion. All right, last thing, we are going to write inequalities from various information. Number 1 says you are creating necklaces for your business. Each necklace you make must be a minimum of 75 millimeters. Rectangular beads are 10 millimeters long and circle beads are 4 millimeters long. Write an inequality that represents a situation. This is a really good situation for me to write in standard form of an inequality. It says that the necklace must be a minimum of 75 millimeters. That's a total, okay? So I'm going to put my total over here. My total is 75. Now, 75 is the minimum. And remember that your inequality symbol always wants to eat the bigger thing. If I write my inequality symbol like this, that means that 75 is the maximum it can be. So I don't want to do that. It can be 75, but it just can't be anything less than that, okay? So rectangular beads are 10 millimeters long and circle beads are 4 millimeters long. So I'm going to have my rectangular beads represent X and our circle beads represent Y. So we are going to have 10X plus 4Y is greater than or equal to 75. So there's my inequality that represents the situation. And then part B says, would you be able to make a necklace that has 4 rectangular beads and 7 circle beads? So I'm going to take this and plug that in for my X, and I'm going to take this and plug that into my Y into the inequality that I got up above. So that's going to be 10 times 4 plus 4 times 7, and that needs to be greater than or equal to 75 to work. This is 40 plus 28 is greater than or equal to 75. That is 68 is greater than or equal to 75. Is that true? No, it is not true. So I could not make a necklace with 4 rectangular beads and 7 circle beads. Number 2, it says you are responsible for ordering desserts for a party and are given a budget of $100. Budgets mean that somebody gives you $100 and that's all you get. So you could not spend more than $100. $100 is the max you can spend. You want to buy 2 different kinds of dessert, mini bundt cakes and cake pops. Each bundt cake is $2.50 and each cake pop is $1.25, right? An inequality to represent the situation. So again, my budget of 100 is my total. So I'm going to have 100 here, and we said that 100 is our max, okay? So my inequality symbol needs to eat the bigger thing, which is going to be the $100. My mini bundt cakes, my mini bundt cakes, each bundt cake is $2.50. And each cake pop is $1.25. So we're going to say our bundt cake is X and our cake pop is Y. So we have $2.50 per bundt cake plus $1.25 per cake pop should be less than or equal to 100. Would I be able to order 25 mini bundt cakes and 35 cake pops? Let's check it out. $2.50 times 25 plus $1.25 times 35. And that should be less than or equal to 100. I am going to pull up my calculator for this because I don't know. That's too much math to do in my head. Okay, so we've got 250 times 25. That is 62.5. And then we've got 125 times 35. And that is 43.75. And that better be less than or equal to 100. So we're going to do 62.5 plus 43.75, and that is 106.25 is less than or equal to 100. Is that true? It is not, so I cannot buy that. Now, it says, well, would you be able to order 20 mini bundt cakes and 40 cake pops? Let's try that. So we've got 250 times 20 plus 125 times 40. That should be less than or equal to 100. So we're going to do 250 times 20, which is 50. And then we've got 125 times 40, which is also 50. Yay. I don't need a calculator for that. Is 100 less than or equal to 100? Yes, it is. So I could buy that, that different amount of mini bundt cakes and cake pops. All right, y'all, that's a lot with inequalities, but none of this is like super brand new. It's just taking things that you already know how to do, like graphing a line and just adding one more layer to it, writing an equation, just adding one more layer to it. All right, that's all I have for you. If you have any questions about inequalities, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video.